Today I would like to discuss about Faraday's first law. Faraday's first law. See, this topic is the subtopic of electrochemistry. Electrochemistry. See, Faraday's first law is states that the amount of substance deposited at electrode is always directly proportional to the amount of electricity used. That means the Faraday's first law indicates that the amount of substance deposited at electrode is directly proportional to the amount of passage of electricity. See, so by equations we can observe some things, that is amount, that is here we are let us indicate by W, and which is directly proportional to the current what we are using to deposit this much of amount, that is here indicated as Q. Okay, see, we know already Q is equal to I into T, so the amperes per time. So if you substitute, then W is proportional to I into T. Okay, I into T. So this is the proportional. So for equating we are using one proportionality constant, that is W is equal to Z into I into T. Okay, so here this proportionality constant Z is called as chemical equivalence. Chemical equivalence. This is the constant. This is the constant. Now, before going to this, we have another term, that is Faraday. That is Faraday. See, Faraday is equal to 1 mole of electrons charge. So we know 1 mole means 6.023 into 10 to the power of 23. So 1 electron's charge is 1.602 into 10 to the power of 19 coulombs. 19 coulombs. So if you multiply these two, so you can get the approximate value, that is 96,500 coulombs. So finally we can say 1 Faraday is equal to 96,500 coulombs. Okay, so this is a 1 mole, 1 Faraday is equal to 96,500 coulombs. See, here we are indicating that 1 Faraday is equal to 1 mole of electrons charge. See, if you want to, for example, here I am taking Al plus 3 plus, so this is the charge here, I am 1 mole, so 1 mole of Al 3 plus. So for depositing these 1 mole of Al 3 plus, here we have to use 3 mole electrons charge. Okay, so 1 mole electron charge is equal to 1 Faraday, then 3 moles electron charge is equal to 3 Faraday. So 3 Faraday of electricity is used to deposit 1 mole of Al3 plus. Here 1 mole of Al3 plus means that molar mass is 27 grams. Okay, so 27 grams of aluminum is deposited by using 3 Faraday. For 1 Faraday, so how much amount can be deducted? That is means deposited, that means that is 27 by 3 grams. So this is 9 grams. This is nothing but equivalent weight of aluminum. This is the equivalent weight of aluminum. So finally we can say 1 Faraday of electricity always 1 Faraday of electricity always discharges 1 equivalent weight of substances. Equivalent weight of substances. Is it clear? Okay, apart from this, if you go through the initial concept, that is Z. Okay, so we already know Z means the amount. Z means amount deposited by passaging of 1 coulomb electricity. But we know E grams. See, here we are taking equivalent weight. So for, let it be E grams. For E grams it required 1 Faraday. So 1 Faraday means that is 96,500 coulombs. So 96,500 coulombs can be deposit E grams. So for 1 coulomb, how much it is? That is E by 96,500. That is grams. So for passaging of 1 coulomb electricity, so the deposited amount is E by 96,500 grams. So this amount is equal to Z, that is chemical equivalence. Okay, so this is the Z value. So if you substitute this Z value in the initial equation, so Faraday's equation, W is equal to Z into IT, then W is equal to Z means that is E by 96,500 into I into T. So this is the final equation for Faraday's first law. Thank you.